Assignment 3.4, divide complex numbers. I think you'll be happy in this assignment that we're actually going to go over the first 4 questions together in this video. And then you'll have the last 4 to do on your own. But let's kind of refresh our memories. What is a complex number? A complex number is a number that's kind of written with 2 parts. The complex number, first off, it has a real number, a number that we're very familiar with, but then that number is going to be added or subtracted by an imaginary number. Remember that real numbers and imaginary numbers can be added or subtracted together. So a complex number is just where you have these kind of 2 different types of numbers being added or subtracted. So if you look at question 1, it says for questions numbers 1 through 4, use the following complex numbers. Here you can see what we have here. You have this, look at D, you have this real number 2 plus this imaginary number I. Here we have the real number 3 minus the imaginary number 3i. Now I guess A up here, this could technically just be called an imaginary number. This wouldn't necessarily be complex. I guess if you wanted to, you could write it as 0 plus 4i though. But yeah, the rest of these would be called complex numbers. So here we're asked to divide these complex numbers. Question 1 says find and simplify b over a. So how do we do 9 plus 2a, or 9 plus 2i divided by 4i? Well, there's kind of an unwritten rule in algebra that you're never supposed to leave an imaginary I on the bottom of a fraction. So this 4i is considered unacceptable. I'll be honest, I don't really know exactly why that is. I'm sure there's a great reason, but for now, just kind of take my word on it. We're not supposed to leave an I on the bottom of a fraction. So here's a little trick we can do. What we're going to do is we're going to actually multiply the top and the bottom of this fraction by I. Okay, now let's watch what happens. So this is kind of a distributive property. This would become 9i plus 2i squared. Remember, when you take an I times an I, you get I squared. And let's go ahead and simplify this. Remember that I squared really transforms into -1. So this is 2 times -1. This meaning we can write this now as 9 minus 2. This 2 times I squared becomes a -2. So we can write this as, 9i minus 2. And then traditionally, we would actually flip the order on that. Traditionally, the real number comes first. We're going to write the -2 first. And then this 9i is positive, so we're going to write it last. So when you take 9 plus 2i and you multiply it by I, ultimately you get -2 plus 9i. Now the bottom's a little simpler. Here when we take 4i times I, we get 4i squared. Well, we know that I squared is equal to -1, so this really just means 4 times -1. It equals -4. So this is considered the proper way to write an answer when you divide 2 complex numbers. Now, I'm going to go ahead and circle this as my final answer. You can see the choice here. There is a little bit of debate on what's the most simplified way to write a problem like this. I would encourage you in this case to just leave your answer like this. You could, you are allowed to kind of write this as 2 separate fractions. Okay, where the -2 is being divided by the -4 and the 9i is being divided by -4. And then you can try to simplify those fractions. -2 over -4 simplifies to 1/2. Actually write it like this, 1/2 minus 9i over 4. 9/4 as a fraction does not simplify at all. So some people would insist, some teachers might insist that you write it as this, a little bit more of a simplified fraction. As far as I'm concerned, I'm content right now. We're just going to leave our answer right here, combined into 1 fraction. So question 2 now, we have to find c divided by b. And this one is going to be trickier. 3 minus 3i divided by 9 plus 2i. Well, this one's going to be trickier because, again, in order to divide these, we need to get rid of this imaginary I in the denominator of the fraction. And that's easier said than done. How would you get rid of this I? See, the problem with 9 plus 2i, if you try to just multiply it by an I and distribute, 9i plus 2i squared. You would end up with 9i minus 2. And the problem is you still have an I. You would still have an I in this denominator. So just multiplying this denominator by I isn't going to fix anything. What we're going to do instead is I want to introduce you to a term called the conjugate. Let me write this down here as kind of as a note. The conjugate of 9 plus 2i is 9 minus 2i. All we did is change the plus sign to a minus sign. We're really just taking the opposite sign of what we see here. This is a plus sign, we make it a minus sign. And here's the beauty of a conjugate. If you multiply any complex number by its conjugate, and so I'm going to go ahead, I'm going to multiply the top and the bottom of this fraction by its conjugate, 9 minus 2i. But here I'm actually going to start with the bottom first. Watch what happens. I should write my answer down here. Watch what happens as we FOIL the bottom, these two conjugates together. So we're going to get 9 times 9, which is 81. We're going to FOIL then 9 times negative 2i, which is minus 18i. We're going to do this positive 2i times 9, which is positive 18i. And then we're going to do 2i times negative 2i, which is negative 4i squared. Now here's the beauty of a conjugate. Look what happens with my I terms here, my minus 18i and my positive 18i. Those cancel each other out. And a negative 4i squared, remember I squared is just negative 1, so this negative 4 times I squared actually becomes a positive 4. This will become 81 plus 4. And look, 81 plus 4 is just 85. And so here's the beauty of a conjugate. Anytime you take, let me write a little rule out here. Here's the little rule. Anytime you take a complex number, like 9 plus 2i, and you multiply it by its conjugate, 9 minus 2i, your answer is always going to be a real number, like 85. Okay, so that's the beauty of being able to multiply two conjugates together. It's always going to come out to this just real number. It's no longer imaginary. Okay, so this is the trick. If we want to get rid of the I in the bottom of this fraction, we're going to multiply it by its conjugate. Okay, now we need to finish this problem off by FOILing the top here. 3 times 9 is 27. 3 times negative 2i, negative 6i. Negative 3i times 9 is negative 27i. And negative 3i times negative 2i is positive 6i squared. Now these, of course, were not conjugates, so this answer won't be quite as easy to combine together. I know that this plus 6i squared, I squared is negative 1, so this will turn into a minus 6. And I'm going to go ahead and combine. 27 minus 6 is 21. And I can also combine these imaginary terms as well. Negative 6i minus 27i is minus 33i. So final answer, 21 minus 33i over 85. And you could try to like simplify these fractions further. It's just not going to happen. Here is our answer, 21 minus 33i over 85. All right, let's keep upping the level on these. So here we have to find b times c over d. So there's a few things going on here. So right off the bat, I'm going to have to FOIL these numbers on the top before I can even try to mess with the conjugate. I'm going to do that off to the side here. So to save time off to the side, we went ahead and FOILed these together. This is something we practiced in the last section. So this becomes 33 minus 21i over 2 plus I. I need to divide these complex numbers. The way I do that now is I multiply the conjugate. The conjugate of 2 plus I is I just flip this plus sign into a minus sign. It'd be 2 minus I. And if you feel better, you can actually always put a 1 in front of the I if that helps you out. But we're going to multiply the top and the bottom of this fraction by 2 minus 1i. I'm going to go ahead and work the FOIL out off to the side on this one as well. And here off to the side you can see when we FOIL 33 minus 21i times 2 minus 1i, this is what we get. 45 minus 75i. And let's pay close attention now to the bottom here. What happens when we multiply these two conjugates together? Well, 2 times 2 is 4. 2 times negative 1i is negative 2i. 1i times 2i is 2i. Now look, you notice how these are going to cancel out? That's a good thing. And then 1i times negative 1i, that'd be negative 1i squared. Well, mission accomplished with our conjugates. Since we get a minus 2i and a plus 2i, those cancel out. Here we have a minus 1i squared. Since I squared is negative 1, that's going to actually turn this into a 4 plus 1. So 45 minus 75i over 4 plus 1. 4 plus 1, of course, is just equal to 5. Now here's a case where we actually can simplify this fraction very easily. We can actually divide, both of these numbers are divisible by 5. So 45 divided by 5, that is 9. And then 75 divided by 5, that's 15. So here's a case where the fraction really simplified very nicely. We're left with this complex number 9 minus 15i. Question 4, I think, is actually a little bit easier. We have to take a plus b over c plus d. Well, adding complex numbers, very easy. When we have to take 4i plus 9 plus 2i, all you do is you add the, we're just going to add these imaginary parts together. 4i plus 2i is 6i. Likewise, when we have to take 3 minus 3i plus 2 plus I, and I'm going to put a 1 in front of that I, we're going to take the 3 plus the 2 is 5. The negative 3i plus the 1i would be a minus or a negative 2i. Okay, so this now is going to be very simple to question number 2. We're going to multiply the top and the bottom of this fraction by the conjugate. This will eliminate the I in the bottom of my fraction. Let me start. I'm going to off to the side. I'm going to go ahead and FOIL these tops together. And you can see here when we FOIL 9 plus 6i times 5 plus 2i. If you'd like to see the steps, here's the FOIL process. But that simplifies to 33 plus 48i. 33 plus 48i. And then let's actually watch this entire process through again. Here we're multiplying two conjugates. So my i's should cancel out. 5 times 5 is 25. 5 times positive 2i is positive 10i. And then look how this works. Negative 2i times 5, that makes a minus 10i. And again, right off the bat, you're going to see my i's cancel out. Lastly, we have negative 2i plus times positive 2i. That's a negative 4i squared. I squared is just equal to negative 1. So this minus 4i squared is actually going to become a plus 4. And 25 plus 4 now become 29. Now you can mess around with these fractions, but they're not going to reduce at all. That is my final answer. All right, complex numbers. I know they're bizarre. I know that it's really hard to find practical applications. Complex numbers, this is just one of those things you just kind of have to learn to accept. It's a part of Algebra 3, and it's something you're expected to know. So keep practicing. The more practice you put into this, the better you're gonna do. Question 5, you can see the complex numbers have changed. We now have T, U, and V, but they're gonna be very similar to the first 4 that we did. Hey, I wish you the best. Let me know if you have any questions. Bye.